All right, y'all. So what I'm going to let y'all do is have a second and copy these down, or if you can do a screenshot on your computer, that way y'all have these 7 basic graphs. So these are the basic graphs we're actually going to be moving around when we do these transformations. So y'all, let me give y'all just a second in case y'all are doing these by hand and writing them down. And I'll put a copy of this in Blackboard later today. That way you'll have another place to find these, okay? And then you want to know the shapes of these when you do math lab later. So you got the y equals x is the identity function. Squaring function, y equals x squared. Square root function, y equals square root of x. Cubing function is y equals x to the third. Cube root, y equals the cube root of x. Reciprocal function, y equals 1 divided by x. And then absolute value function, y equals the absolute value of x. So we played with a few of these. Now we don't have to actually know how to graph these lines. We just need to know what these shapes are so that when we move them around. All right, so I'm gonna go to my pad and get us started. All right, so 7.2 deals with transformations. And I guess to me, transformations means moving the graphs around. I can move the graph up and down. I can move the graph left to right. I can flip the graph over the x-axis. So those will be the 3 major transformations we're looking at. So first of all, we will look at what we call a vertical shift. All right, so vertical shift would be y equals f of x plus or minus b. So we take a number and we add or subtract that number from our function. So I'm going to give you 2 examples. If I had y equals x squared plus 2. So x squared is my f of x, and I'm adding 2. If I add to my function, this is going to move the graph up 2 units. So if the b is positive, like this plus 2, it's going to move the graph up. If I subtract from the end, say I took my x squared graph and I subtracted 3. If I subtract 3 from my function, that's going to move the graph down 3 units. So the moral of the story, if b is positive, then the graph moves up. If b is negative, then the graph moves down. And y'all, it don't matter which one of them 7 basic graphs I use. If I add, it's moving it up. If I subtract, is moving it down. So that's how we get our vertical shift, by adding or subtracting a number from the end of the function. So you got to be careful. The next one is a horizontal shift. Horizontal shift moves left or right. So that'll be y equals f of x plus or minus d. Notice the difference. Up here, you added or subtracted to the end of the function. Here, you're changing the x value of the function. So y'all watch this one. Y equals x plus 1 squared. So notice the difference. I didn't add it to the end of my function. I changed the x value of the function. So when you change the x value of the function, it's going to move left or right. So this one will move left 1 unit. So if you add to the x before you square it, it's going to move it left 1 unit. Now, likewise, if I subtract from my x before I square it, subtracting moves the value to the right. So this one would move right 2 units. So vertical, adding up, subtracting down. Horizontal, adding goes left, subtracting moves right. So if B is, whoops, I'm using D. If D is positive, then the graph moves left. If D is negative, then the graph moves right. And y'all, the last shift we'll look at is a reflection over the x-axis. So that'll look like y equals negative f of x. So if your function was positive, this negative is going to make all those y values negative instead of positive. So for an example of that, y equals negative x squared. So what that negative is going to do is it's going to reflect the graph over the x-axis. Now, we can reflect over the y-axis, but we're not going to mess with that at this time. The only 3 shifts we'll do is a vertical shift, horizontal shift, and we'll reflect it over the x-axis. I was going to let y'all write that real quick, and then I'll start showing y'all some examples. Now, we'll say this. The identity graph that was y equals x, that's the only one that I cannot do a horizontal shift to left and right. And I'll show you that. I think that's like my second problem. So what I'm going to do is go to, I'm going to take you to the math lab and show you what these problems look like. All right, so here we want to describe how the given function can be obtained from one of the basic graphs, and then we're going to graph the function. So let me get you the basic graphs real quick. So remember, here's my basic graphs. Y equals x, y equals x squared, y equals square root of x, y equals x to the third, y equals cube root of x, y equals 1 divided by x, y equals absolute value of x. So the basic graphs will be one of these 7 graphs, okay? So first thing I'm looking at on this problem, y'all, is I see an exponent of 2. Since that's an exponent of 2, this would be the y equals x squared graph. Now, what we got to do is figure out what they're doing to my graph when they subtract 4 from the x inside the parentheses. Oh, that's pretty quick. Y'all said move it right 4 units. So yeah, the 4 treated like the D, remember it's inside the parentheses. So we need to pick the one that says we went right 4 units. So that'll be C. And then what you got to do is put in the basic graph, which was the x squared. So we would have to punch in our x and then go down here and square it. So y'all, once you do that, you'll check and move on to the next one. Whoops, they want us to graph it. So this is what I mainly needed y'all to see. So watch what I do. I'm going to click it to graph it. So the x squared graphs look like the parabolas. So I'm going to click the one that says x squared tool. Now watch this. Once you click it, go to the graph, anywhere on the graph and click it. It's going to put it in the center like the basic graph would look like. But notice, it opened up a little box here. Now, we don't worry about the shrinking and stuff. We're worried about down here where it says vertical shift, horizontal shift. And if we reflect it over to X, we got to check that box. So y'all said this one went, what, 4 units to the right? So you'll go over here to the horizontal shift and drag that until you get it to a positive 4. As I move that slider, look at my graph. My graph is now got the bottom point sitting at the 4 on the x-axis. So it moved it from the center to the right 4 units. At that point, y'all will just save it. And then you have to check your answer and move on. Well, let me see, that's the same. All right, y'all look at this one. G of x equals x minus 4. So that's not inside parentheses with the x. That negative 4 is just sitting at the end of my function. So any guesses on what that negative 4 is going to do? And y'all, I'll tell you this, you'll treat that negative 4 like the b. So y'all said, let's see, move it down 4 units, perfect. So I need to find the one that said shift it down 4 units, which would be C. And this would be the y equals x graph. So we just put in an x in that, and you would check your answer. Now, y'all, this is the only one where you actually had to graph it. So you would have to put in 2 points. So grab this line tool. So if I let x equal 0, when x is 0, 0 minus 4 would give me a negative 4. So I'm going to come down here to negative 4 and click. And let's say x is 1. If x is 1, 1 minus 4 gives me a negative 3. So I'll go to 1, negative 3, put my second point. The line tool is the only one where you physically have to graph it, okay? So at that point, you'll save it and move on. All right, y'all, so let's see what y'all think. Now they're telling you, how can the graph of h of x equals 1 divided by x minus 6 be obtained from the graph of f of x equals 1 over x? So they're telling you what the basic function is, the 1 over x graph. So what is the minus 6 doing to my graph? Let's see, y'all got A. So what's A? Shift it down there. That's it, right? Subtracting 6 at the end moves my graph down. So we would check our answer, and y'all gonna pick A, B, C, or D. And I'll tell you on the truth, C looks like the basic graph, right? C looks perfectly like the basic graph. So y'all said A again. So A looks like it went down. And B looks like it went up. So since we went down, we would pick A and check that one. All right, y'all, questions on these yet? If not, we're gonna keep on going to them then, okay? Now this one here does not give me the basic function. They're giving me g of x equals negative times x minus 3 in parentheses to the third power. And y'all, I'm going to look at some of these answers. B and C, we would throw them out no matter what, because they're talking about the y-axis. We're not flipping anything across the y-axis in this section. So we either got to go with A or D that talk about the x-axis. So y'all got D, let's see. Oh, perfect. The x minus 3 is in parentheses. So when we subtract it, it does move right. So we would pick D like y'all said. Shift it right 3 units and reflect across the x. Now, the basic graph would be x to the third. So we would put x, and then our exponent would be to the third. So a lot of these, if they got exponents, they're sort of getting you good on which graph you would go to, okay, on the basic graphs. So y'all watch this. We're going to have to graph this one. So it says check answer. So I'm going to click on enlarge my graphs. Now remember, the cubic one looks like the squiggly line, and it calls it the X cube tool. So click that, and then click anywhere on the graph. It's going to put it in the center no matter where you click it. So y'all said this went right 3 units. So you come down here to horizontal, put that on +3. So it moved it over. Now to reflect it over the x-axis, I'm going to come down in the bottom left corner where it says vertical flip and check that box. Once I've got that checked, I can save it and then check my answer. So I think these are easier to graph than some of the problems we had in the past. Because this one, you just got to figure out which basic graph you got, then use them slides. All righty, so they're giving me g of x equals x plus 4 squared minus 1. So the basic graph would be f of x equals, so I see that exponent 2 there. So I'm going to figure out that's what the x squared graph. I'm going to hit my x and square that. Now, it says shift it blank 4 units. So that 4 is inside the parentheses. So let's see, y'all said 4 units, so that's perfect. So you click the arrow and we'll go down here and pick left like you said. And then shift it blank 1 unit. So what about that part? So right, left, up or down. So y'all said down. So we click down, y'all. So left 4 units, down 1, check our answer. Now, when you do your transformations, we will start with the x squared graph. Click on the graph anywhere. Y'all said what? Left 4 units. So horizontal goes to -4. So it moved it left 4. And y'all said down 1. So vertical, we would move to -1. So it moved it down. Save that. And go to your next question. Y'all, this is the square root graph. So let me just tell you a trick. Anything that's under the square root, you would treat it like it's in parentheses, okay? So they're telling us you're going to start with the graph gx equals square root of x, and then shift it blank units. So is that -3 going to take me up, down, left, or right? So it is definitely going to go right. So we would click right. And then y'all, we would put in our 3. So both y'all got that and good job. And then check our answer. Now I bet we got to graph that. Let's see. Oh, so this one, A, B, C, or D. Which one of these pictures looks like it went right 3 units? Yeah, Claire, I'm thinking B too. It looks like it's a little bit to the right, 3 units. A looks like it went up. B does look like it went right. C looks like it went down. And then D went left. So the only one that could possibly went right was RB. And then check the answer. So they're nice on some of these. You just pick the answer. Some of these you had to actually graph it using the slide controls. All right, y'all. So we're going to start with the cube root of x plus 6. So if the cube root of x is my basic graph, what did that plus 6 do to our graph? A, B, C, or D? So I got C hitting me. So let's see, what is C? 6 units up, looks good. So we're going to click our 6 units up. Check that answer. Then it's going to make this graph, and I'll bet. So which one of those, A, B, C, looks like it went up 6 units? Oh, I'm seeing a lot of C's, so definitely C went up. B is the basic graph going through the middle, and I guess A looks like it went down. So y'all check that. All right, number 8. Now this one's tricky on the graph, and you got to graph it when you're doing it moves, do them in the same order as they're asking them. So they're saying we got negative x minus 3 squared plus 2. So the first thing we're looking at is the first move is inside the parentheses. So what did that -3 do to my graph? So let's see, it's negative, so it went to the right. So y'all got right 3. So we're going to go right 3. Good job. Then reflected across the and y'all know there's only one we can choose on here, right? There you go. X-axis is all we're choosing in this section. So I guess y'all got to figure out what that +2 is doing. Up 2. All right, so we would check that answer. Now, oh, I don't guess we got to graph that. Also, that's all we had to do on that, and just figure out the moves, and then we're good. So y'all, let me ask you this. Any questions on that? Oh, let me take this one. We missed one somehow. Let me see. I don't think I answered it, I guess. All right, so we're going to go back and do this so we can get this in right. X minus 10 squared. So what is that minus 10 doing to this graph? So it's going to be right 10. So let's see. That would be what, B? And then I guess we started with our x squared graph. So x and square that. I don't think I actually submitted it earlier. Oh, what I do? Oh, I see what I did. I got too many boxes on my x squared. So let me go remove one of them boxes and just make that an x squared. All righty, so it should like that. And then graphing it, x squared would be the parabola, so just click it anywhere. We went right 10, so that would be horizontal all the way to 10. So there we go. Save that and be done. All right, y'all. So questions on that? All righty, so let me go back to my pad. And y'all, let me just show you this. Screenshot this, or I tried to send y'all this in email, but Plasky Tech email told me that my picture was too large, so it wouldn't let me send y'all this picture. So get a picture with your phone or screenshot it on your computer. I will send it to Blackboard later so that y'all got the 7 basic graphs, okay? All right, so I'm gonna go to my pad. I'm gonna sort of do a review to get us ready for Wednesday. So I'm gonna show you what we're gonna play with Wednesday. So have y'all seen that before? So definitely quadratic formula. Now let me go back. Let me see what this question says. Are we going to do some on the calculator? You can graph them on the calculator, but I don't really use mine for those. Because MathLab just has you shifting them with their buttons and stuff. But yeah, y'all could do those on the calculator if you wanted. Now, y'all notice this quadratic formula. I will say this. The trickiest part of this quadratic formula is that radical section right in here. If you cannot simplify a radical, You're not going to be able to simplify using this formula. So I'm going to review y'all on simplifying these radicals for a second. Now, I'm going to make a list of numbers that I call perfect squares. Perfect squares are numbers that multiply by themselves, and they have perfect square roots. So 1's the smallest square because 1 times 1 is 1. Square root of 1 is 1. 4 is the next perfect square. Square root of 4 would be 2. So let me write the ones I'm sort of worried about at the moment. So this is the first 15 perfect squares. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4, and so on. Okay? Now, what is the square root of 9? So that's one of the answers. 3 is one of the answers. What's the other square root of 9? -3. There you go. So that I could write this as a plus or minus 3. That means 3 is the square root, also -3. Yo, that's why the quadratic formula has a plus or minus there. If the square root is, we take the square root, first time we'll treat it like a positive and add it. Then we'll treat the square root like a negative and subtract it from our negative b. So that's all that plus or minus is there, is to let you know that square roots can be positive or negative, because 2 negatives will make a positive, okay? All right, square root of 49. Oh, I'm not getting no responses. How about that would be what, a plus or minus 7? So if it's a number that's in this list, it will have a perfect square root, okay? So y'all, square root of 20. 20 is not in my list. So 20 does not have a square root. But what we want to do is simplify this. And we would simplify the square root of 20 by removing any factors that are perfect squares. Oh, I see what you're doing. So think about it this way. Let me ask y'all this. Oh, so someone's got 2 square root of 5, which is actually going to be what I get to. So what we do, 20. If any of these numbers are a factor of 20, we're going to rewrite the radical. So 4 is a factor of 20. So what we would do is make this a square root of 4 times the square root of 5, because 4 times 5 does give me 20, right? Now, to simplify this, the square root of 4 could be plus or minus 2. We couldn't do nothing with the square root of 5. So we bring down that square root of 5. So to simplify a radical means to pull out any of these perfect squares that are factors of that 20, okay? So let me do this one with y'all. How about 28? So 28 is not a perfect square root, but does 28 have any factors that are perfect squares? And we don't have but a few to choose from, right? So let's see. Looks like I did a 4 again, right? 28 divided by 4 gives me what, 7? So you would write the 28 as a square root of 4 times square root of 7. And then the perfect square has to come out, so we'll make that a plus or minus 2 square root of 7. There you go. What about this one? What about a square root of 27? Well, y'all, 27 ain't in my list. Does 27 have a factor that's a perfect square? And usually I'll just start dividing by these and see if I get good numbers out of it. But 9 divides into 27. So you would make this a square root of 9 times the square root of 3. Ooh, y'all done got it. What, 3 square root of 3? There you go. Because the square root of 9 is 3. And then bring over that square root of 3. Square root of 31. Can that be simplified? So let's see. 31 won't divide by 4. 31 won't divide by 9. 31 won't divide by 16. And everything else is getting a little too big. So yeah, so since it does not simplify with any of these perfect squares, it would stay a square root of 31. Okay. All right, y'all. So remember these numbers I'm about to ask y'all. What about the square root of a negative 9? Now, 9 is a perfect square root, but y'all, negative 9 isn't. So what we do when we got negative numbers under these square roots, oh, Kara, that's a good job, 3i. So let me show them how we got that. So they come up with a rule that says, if we get a square root of negative 1, we're going to let that equal I. So anywhere you see an I, that means it's really a square root of negative 1. So y'all, what they do to this, they break this down into a 9 and then square root of negative 1. All right, so the square root of 9 comes out as a plus or minus 3. Cannot take the square root of negative 1, so we're going to replace it with the I. And that just means this is now an imaginary number, because in the real world, we cannot take the same sign and get a negative 9 out of it, okay? So this means in the imaginary world, I get a plus or minus 3i. So now, knowing that, y'all, what's this give me? Square root of a negative 25. And that's it, 5i. Okay, so basically take the square root of the number, and this negative basically comes out as our I, okay? Oh, let me see what I'm on here. Oh, I want one, but let me see. How about a square root of a -12? So we would probably pick what a perfect square factor would be a 4 for that one. So what you want to do, we'll make that a 4 times the -1 times the 3. So 4 times -1 times 3 gives me -12 still under the radical. And I always put the -1 in the middle because a lot of times if you put it at the end, MathLab thinks it's under that radical. And if it's under the radical, the I part, it'll mark it wrong, okay? So here we go. Plus or minus, square root of 4 is 2. Square root of -1 is I. And then at the end, we bring down our square root of 3. Now let me let y'all try one. How about square root of -45? So let me give y'all a second, let y'all see if y'all can play with that one, okay? Oh, y'all let me get y'all on that one, huh? 3i squared of 5. Perfect. Perfect. Now, the way Carrie got that, she made this into 3 radicals again. And the largest number she found that went into that 45 must have been that 9 sitting there. So she did a 9, -1, and a 5. So y'all remember that's plus or minus, but square root of 9 was 3. Square root of -1 was I. And then she brought down her square root of 5. Alrighty, so let me get y'all ready by showing y'all one of these. So we use the quadratic formula. Now we can factor these also. But sometimes when stuff don't factor, we gotta use that quadratic formula. Remember which was the, so we gotta figure out what A is, B is, and C. So A, B, and C are the numbers in front, and you gotta have it in descending order. X squared, the X, and then your number. So I will say B is 14. C would be the 45. What is A? I do not have a number in front of the X squared, so what's that make my A? All right, so it, oh, 1. Remember, that's a 0. That thing would be gone, right? 0 times X squared would be gone. So remember, that is a 1. Anytime there's not a number there, it's got to be a 1. So now, here's my formula. And I'm going to plug in. So this negative B, all that negative does is change the sign of whatever B was up here. So we got negative times B, which is 14, plus or minus. B squared would be my 14 squared. I use parentheses on that because if you don't put parentheses around that 14 and you put in a -14, for negative numbers, it'll give you the wrong answer. Any number I squared has to come out positive, okay? And then it's minus 4 times A, which is 1, times C, which is 45. All of this will be divided by 2 times my A, which is 1. All right, so first I can simplify these outside numbers and a little bit inside. So that's going to make that a negative 14. So in the long run, it just changes the sign of B up here. There's our plus and minus. 14 squared is 196. There's only one negative on this right side, so it'll stay negative. And y'all, let's figure out 4 times 1 is 4. 4 times 45, that's like 180. All of this over 2 times 1, which is 2. All right, so we can't do nothing with this outside stuff until we get rid of this radical. So bring down your negative 14, plus or minus. Under the radical, 196 minus 180, that gives us 16. All of that divided by 2. So see, you're going along, most of the work is just under that radical. So now we're going to try to simplify this radical. So bring down that negative 14, plus or minus. Square root of 16, we know that. Square root of 16 is a 4. And then on bottom is my 2. Now, this one I can even simplify further because all these numbers will divide by 2. So since all 3 of these outside numbers divide by 2, I'm going to divide everybody by 2. So negative 14 divided by 2 gives me a negative 7. Plus or minus 4 divided by 2 is 2. All right, I'm going to get my 2 answers from this. The plus or minus is the trick. First time I take negative 7 plus 2. Well, negative 7 plus 2 gives me a negative 5. My second answer, I take negative 7 minus 2. So I would do negative 7 minus 2. Negative 7 minus 2 gives me a negative 9. Perfect. And y'all, that's how we find our 2 answers. Now, sometimes, say I worked this and I ended up with a problem that looked like 6 plus or minus square root of 5. If you get this kind of answer with a radical, when you go to Math Lab, they got a plus or minus button, and we can just plug it in one time instead of writing 6 plus square root of 5 and then 6 minus square root of 5. So in that case, we can use the plus or minus and just write it in Math Lab once. But for the one we just did, you would have an x equals, and you would just come in and put your 2 answers. Whoops, negative 5 and negative 9, and be done with it. So you don't have to know this yet. I just wanted to give y'all a preview of what we got coming up Wednesday when we deal with this quadratic formula. So it's not too fun. I mean, it's, if you can factor, that's probably the quickest way to solve some of these. But all of these might not be factorable. So the only one that's guaranteed to solve every one of these quadratic equations is the quadratic formula. So it's a little tedious, but it works every time, okay? And we just got to get y'all good at simplifying that radical part. Once we can simplify the radical part, this stuff not too bad, okay? So for tonight, I need y'all to do 7.2, get that caught up with your transformations. And then we'll come in, we'll knock out 7.4 and 4.8. They're both doing quadratic stuff, okay? All righty, so y'all, let me just say a few more things. Some of y'all's tests are going in good. If you sent me bonus, I'll probably wait till next Sunday to add the bonus once I've got everybody's test in. But you'll know it, whatever grade you got, if you sent me a bonus, you'll add 5 to that and be good to go, okay? Oh, let me see something. All right. So y'all, any questions on your transformations? So I do have a chat. Let's see what y'all saying. Yeah, the test can only be taken one time. So get good on the study guide. Now remember, the study guide is probably harder than my test because it's got 25 questions. And y'all, I've already had someone out of y'all's class. I won't say no names, but they done like a 80 or so on my review test, and then they made like a 97 on the actual test. Okay. And then once I add bonus points to that, that score is probably going to be over 100. Okay. So this week's sections for homework y'all are asking, it'll be 7.2, 7.4, and 4.8. 7.4 and 4.8 are really small sections. So we'll knock both of them out on Wednesday. 7.2 is not that long, but since there's graphing, I only like to do that one section at a time. So I just use the rest of my time to do that little bit of quad formula stuff. That way we'll have sort of an idea about that quad formula when we hit it Wednesday, okay? All right, y'all, let me look at the chat real quick. So yeah, that's the thing. I would do this, although the review says it's already past the due date, it'll let you work past due dates without penalty. I would definitely I'd want to make at least a 70 on my review quiz before I took that test, okay? And then remember, I sent a video doing all 25 of them questions for y'all. I think I sent it last Wednesday, okay? All right, y'all, so let me stop my recording.